Welcome, this is your teacher David Garcia, and today we're going to be working with the topic of the parabola. Now, in this video, we're going to put everything that we have learned together to graph a parabola. So let's jump right into it. Let's imagine that we are given this conic equation. We have x squared minus 8x plus 2y plus 26 equals 0. So I'm going to start going a little bit faster than usual. If you feel lost in one of the steps, just watch some of the previous videos. So let's begin. We will have 2y plus 26 equals negative x squared minus 8x. To complete the trinome, so this will be 16. So I have to subtract 16 from here. This will be 2y plus 10. And this will be negative x minus 4 squared. So by isolating the y, I will have negative 1/2 of x minus 4 squared minus 5. So once you reach this point, once you reach the vertex form of the equation, now you know that you have all the necessary information to graph the properties. Okay, you have the value for a, which is negative 1/2. You have the value of h, which is 4, and k is equal to negative 5. So from here, we will get the properties. We know that the vertex will be h comma k, so it is 4 comma negative 5. The focus will be h comma k plus 1 over 4a. So we will have that the focus is found at 4 comma, and then the operation in here will be negative 5 plus 1 over 4 times negative 1/2. And if we put this in the calculator, this will be negative 11/2, all right? Or in other words, negative 5.5. Now, the axis of symmetry is x equals h, so it'll be x equals 4. Then our directrix is y equals k minus 1 over 4a. So it'll be basically the same operation as before, but with negatives. So it's 5 minus 1 over 4 times negative 1/2. We put this in the calculator and we get that this is negative 9/2. So y equals negative 4.5. Now, after the directrix, we know that the opening will be pointing downwards. And finally, the length of the lattice rectum, we know that it will be the absolute value of 1 divided by a, that in this case is negative 1/2. So this is 2. So now we're going to use all of this information to graph our parabola. We're going to start with the vertex, then the focus, then the axis of symmetry, directrix, and finally we will use the length of the lattice rectum And from there, we will be able to draw our parabola. So let's jump onto the graphing calculator. I'm going to show you in here what the idea is. Okay, the grid that you are looking at in here is very much the grid that you have on the millimetric paper. If you don't have it, you will have to do some compromises. Let's imagine that we're working on millimetric paper. So let's begin by drawing the vertex. The vertex in here will be found at 4, -5. So that means that right in here, we're going to have our vertex. So there it is. There's our vertex. And now our focus. Our focus is located at 4, -5.5. So that means that from this 5.5, we're going to move all the way up to 4. So just a little bit down from the vertex, and we will have our focus in there. And there we go. So we have marked the vertex and the focus. Now the axis of symmetry will be the line in this case that unites these 2 points. So in here, I'm representing it by a green dashed line. I'm going to put it at the end so it doesn't get in the way. So we have the axis of symmetry in there. Very easy. Now the directrix. The directrix, if you remember, it'll be found exactly at the same distance, but on an opposite direction from the vertex to the focus. Meaning that in this case, if you remember, the line that we need to draw will be at -4.5. So in this case, this will be our directrix. And here we go. Our directrix is this blue line in here. Now we know the opening will be downwards. And finally, the length of the lattice rectum. The length of the lattice rectum, if you remember, has to be measured from the focus to each one of the sides, right? That is to the right and to the left. So from the focus, if I have 2 units, I will divide them. And I will measure, in this case, 1 unit to the right and 1 unit to the left. And in here, I will mark my points. These points are the beginning point and the ending point of the lattice rectum. The lattice rectum will be this line in here. So we are almost done. From here, it's just a matter of drawing from the vertex a curved line all the way up to this point of the lattice rectum, and I do the same exactly onto the other side. And from there, I just go downwards in a normal parabola way, and I should end up with something like this. And that's it. That's what you have to do now. If you have any questions, I'll see you in class. Good luck, and I'll see you in our next video.